Okay, today we're diving into the high-stakes race for the materials that basically power our entire modern world. We're talking about rare earths.
So, let's start with a question. What do an electric vehicle, a giant wind turbine, and a fighter jet all have in common? I mean, they seem worlds apart, right? But they all share this one secret and totally critical ingredient.
And that shared ingredient is a group of 17 minerals we call rare earth elements. And look, these aren't just some obscure metals. They are literally the foundation of our entire high-tech economy.
So what makes them so special? Well, these aren't just rocks. You can think of them as the indispensable ingredients, the magic minerals that make our modern technology even possible. Officially, rare earth elements, or REEs, are a set of 17 minerals that have these incredibly unique and powerful properties. We're talking about things like magnetism, catalysis, and luminescence. And these properties, they're exactly what engineers need to create smaller, faster, and way more powerful technology.
And their applications are, well, they're everywhere. We're talking about the super strong, super lightweight magnets inside an EV's motor, or a wind turbine's generator. The lasers in our communication systems, essential components in your smartphone, your hard drive, and even our most advanced defense systems. They're truly the hidden engine of our world.
And demand is just exploding. The market is projected to hit nearly $8 billion by 2030. But here's where the story gets complicated. Just look at those last two numbers. One single country, China, mines about 70% of the world's supply. And then it produces a mind-boggling 94% of the high-performance magnets. This incredible concentration of power, well, it sets the stage for a major strategic challenge.
And that brings us to the core of the issue, the great supply choke point. You see, just getting these minerals out of the ground, that's only half the battle. The real fight, the real challenge, comes next. This number right here reveals the true scale of the choke point. So while China mines around 70% of rare earths, it processes and refines roughly 90% of the entire global supply. Think about that. That means even ore mined in other countries often has to be sent to China just to be turned into usable material.
This is where the real power is. It's not just in the mining, it's in the complex, super technical process of separating and refining these elements. This is the stage where you turn raw ore into the high-purity metals needed for all that advanced tech. If you control this step, you control the entire supply chain, period.
Now, this level of dominance didn't just happen by accident. Oh no, it's the result of a very deliberate 4-decade-long industrial policy, one that took advantage of lower costs and, frankly, less strict environmental rules that made processing elsewhere a lot less attractive. And this has given China immense strategic leverage, allowing it to use tools like export controls and creating huge, huge risks for manufacturers everywhere else. So, in response to this major vulnerability, we are now seeing what you could call a warp-speed effort from a coalition of nations. They're literally racing to build a parallel supply chain, one that isn't dependent on a single point of failure. The key players in this new alliance are the United States, India, Australia, and the United Arab Emirates. And what's interesting is that each country is bringing a different piece of the puzzle to the table. It's a coordinated effort to diversify the entire supply.
The U.S. strategy is all about what they're calling mine-to-magnet integration. The goal here is a complete, totally self-sufficient domestic supply chain. This includes a ton of funding to expand on-site processing at mines and a massive $1.4 billion investment to build a factory that can make those high-performance magnets right here at home.
Now, India, which actually holds the world's third largest reserves of rare earths, is focused on developing the one big thing it's missing, its own domestic processing technology. So they've put up a nearly $800 million incentive program designed specifically to build those capabilities and achieve some long-term self-reliance.
Australia's role in all of this is to be the reliable supplier of the raw ore itself. As a huge producer outside of China, its strategy is to provide a stable, dependable source of materials for its allies, a concept you might hear called friendshoring. It's really a foundational piece of this whole alternative supply chain.
And then you've got the UAE, stepping in as the key financial partner. It's co-leading a $1.8 billion joint fund, and the whole point of that fund is to fast-track critical mineral projects around the globe. It's providing the capital needed to get new, independent mines and facilities up and running, and fast.
But you know, while digging new mines is absolutely crucial, there might be an even bigger opportunity out there, a potential game changer. What if the most secure source of rare earths wasn't in the ground at all, but was actually hiding in all the devices we've already thrown away?
This number is just staggering. Right now, we recycle less than 5% of all rare earth elements. I mean, just think of all the old smartphones, hard drives, and electronics sitting in landfills. That is a massive, untapped urban mine just waiting to be unlocked.
And this slide really shows the shift perfectly. You see, historically, recycling this stuff was really difficult and dirty. It was expensive and used a lot of hazardous chemicals. But now, new innovations are completely changing the game. We're starting to see cheaper, cleaner, and commercially viable methods pop up that make it possible to efficiently pull these valuable elements right out of our e-waste.
And here is the real strategic payoff. A robust recycling system creates a secondary source that is completely insulated from geopolitical disputes or shipping problems. It is the very definition of a secure, homegrown supply chain. So with all these moving pieces, new mines, new processing plants, brand new recycling tech, it all brings us to the final big question. Who is actually winning this race?
So here's the current state of play. For now, the advantage is still with China, and that's thanks to its 40-decade head start. But the challengers are definitely gaining ground. These coordinated investments are starting to build real capacity outside of China. But make no mistake, this is a long game. Winning won't just be about new facilities, it's going to depend on commercializing advanced recycling to create a truly resilient system.
The race is well and truly on. And it leaves us with a really fascinating question for the future of our technology and, honestly, our planet. Will this contest be won by digging new mines all around the world, or by finally learning how to unlock the treasures we've already buried in our old tech?